Bismillahirrahmanirrahim. Welcome to physics second year lesson. In the previous lesson, we discussed about the spontaneous and stimulated emission and laser action. The main five definitions of the laser topic are spontaneous emission, stimulated emission, and spontaneous absorption, metastable state, and population inversion. First, we briefly revise these concepts in order to understand the concept of laser action. First of all, the spontaneous absorption. If an electron is in its ground state E1 and a photon of energy equal to E2 minus E1 falls on it, the electron absorbs this energy and jumps to higher energy level E2. This phenomena is known as induced absorption or spontaneous absorption. Second phenomena is the spontaneous emission. If an atom is in its excited state E2, it is the unstable state and the atom resides there for a time interval of 10 raised to the minus 8 seconds and naturally jumps back or spontaneously jumps back to energy state E1 by emitting the energy in the form of photon of energy equal to E2 minus E1. The photon resulting due to the spontaneous emission are emitted in different directions. And the third phenomena due to which the laser action proceeds is known as stimulated emission. In this phenomena, if an atom is in its or if the electron is in its excited state E2 and during this time a photon whose energy is equal to E2 minus E1 falls on it, then this incident photon stimulates or forces the atom or electron to go back to its ground state earlier, and as a result, two photons are produced having the same energy and same direction, that is E2 minus E1. This phenomena is known as stimulated emission. Then fourth definition is the metastable state. Metastable state is also an excited state, but in these states, the lifetime of an atom is greater as compared to the normal lifetime. In these states, the lifetime of an atom is 10 raised to the minus 3 seconds, which is larger as compared to normal lifetime, that is 10 raised to the minus 8 seconds. And the fifth definition, that is the population inversion. Population inversion is the situation in which the number of atoms in excited state E2 are greater as compared to the number of atoms or electrons in ground state E1. On the basis of these five definitions, we can explain the laser action phenomena. In this case, we consider three energy states, E1, E2, and E3. E1 is the ground state, where E2 and E3 both are excited states, but E2 is the metastable state and E3 is the normal excited state. First of all, by the phenomena of optical pumping, the photons having the energy equal to E3 minus E1 falls on these electrons, so the electron absorbs this energy of photon and jumps from ground state to excited state or the state having the energy equal to E3. This is due to the phenomena of induced or stimulated absorption. Then in this excited state E3, the lifetime of an atom is 10 raised to the minus 8 seconds. After this time, either the electron will jump back to its ground state or to the metastable state or lower energy state. So when an electron jumps from excited state E3 to E2, then due to the phenomena of spontaneous emission, it released the energy HF equal to E3 minus E2. As E2 is the metastable state in which the lifetime of an atom is greater, that is 10 raised to the power minus 3 seconds, as compared to 10 raised to the power minus 8 seconds, the normal lifetime of an atom in an excited state. So, due to this metastable state, the population inversion is achieved. This is because the time for coming into the metastable state is less as compared to the time for going out of the metastable state. So the population of this metastable state goes on increasing. This can be understood by a simple example. If there is a room having two doors, from one door, the peoples are coming in at a higher rate or quickly they are entering the room, but from the other room, the peoples are leaving the room at a slower rate or slowly. So with time, the number of people inside the room goes on increasing due to the similar phenomena. The population inversion is achieved. Once the population inversion is achieved, then initially these atoms spontaneously decay and emits the photon of energy HF equal to E2 minus E1. Then with the help of mirrors, these photons are reflected back into the entity of laser, which collides or which strikes with the atoms or electrons in the metastable state and produces the stimulated emission phenomena, due to which the laser action starts. So these are the topics which were discussed in the previous lesson. Now in this lesson we will discuss the exercise questions and numericals. According to reduced syllabus of Federal Board, the first question which is included, that is question number 5, explain the difference between the laser light and the light from an incandescent light or bulb. So these are the few differences between these two. First of all, laser light, it is monochromatic or having single wavelength, whereas in case of incandescent light, it contains many wavelengths. For example, the light emitted by incandescent, if it is a white light, so it is containing 7 wavelengths or 7 colors. Whereas in case of laser light, there is only single wavelength or single color. Then second property is laser light is coherent, or all the beams in the laser light have a constant phase difference. Whereas the light from the incandescent lamp, it is not coherent, or their phase difference does not remain constant between two rays of light. Laser light is unidirectional, it travels in only one direction and dispersion is very small, whereas incandescent light, it is multi-direction and it spreads in all directions. Then it is produced by the phenomenon known as stimulated emission, in which all the photons are of same energy and same direction, which amplifies the light. Whereas in case of incandescent light, it is produced by spontaneous emission. And as the light is being amplified, so in case of laser, so intensity of light in case of laser is high, whereas in case of incandescent light, it is low. Next question is, X-rays can emit electron from a metal source and X-rays can be diffracted. Comment. So this is related to the previous chapter phenomena, that is dual nature of light. First of all, the emission of electron from the metal surface by X-rays, which is named as the photoelectric effect. Photoelectric effect is the phenomena in which when a light of some suitable frequency falls on a metal surface, it ejects the electron from these metal surfaces. So when these photons fall on the electron absorbs this energy and they come out of the metal surface. So this is this shows the particle nature of light or particle nature of X-rays, as X-ray also produces the photoelectric effect. Also, when the X-rays are being bombarded on a crystal, it shows diffraction, which is a wave phenomena. So X-rays also produces the wave nature or shows the wave nature. So these two phenomena shows that the electromagnetic radiations or X-ray radiations have dual nature, that sometimes they act as a wave and sometimes it act as a particle. Next question, that is why X-rays have different properties from light, even both are being originated from the orbital transition of electron in excited atoms. So the basic difference is X-rays are produced due to the inner shell transition of electron, whereas the ordinary light is produced due to the transition of valence electron. So this is the basic difference. So the energy of X-rays is very high as compared to the ordinary electromagnetic waves because it is being produced due to the inner shell transition, as the inner shell electrons are tightly bound. So high energy is required to remove them, and when these vacancies are being filled by higher electrons, the light or the X-rays are emitted of higher energy. So the properties related to this are they are more energetic, so their penetration power is also high than the other light. X-ray spectrum consists of both the characteristic and continuous spectrum. Characteristic X-rays are produced due to the phenomena of inertial transition, whereas continuous X-rays are produced due to the phenomena of breaking radiation or bremstalling. Then X-rays cannot diffract from ordinary diffraction grating, whereas they can be diffracted with the help of crystal, whereas ordinary light is diffracted from a diffraction grating. Then X-rays can produce the Compton scattering, but the light cannot do it because the normal light or visible light, its energy is very less as compared to X-ray. Also, the ionization power of X-rays is greater as compared to ordinary light. Next question is, what is meant by the statement that laser beam is coherent, monochromatic, and parallel? So first of all, what is coherent? In case of coherent sources or coherent light is defined that if a laser beam is coherent, it means that all of its photons are in same phase or they have a constant phase difference. Whereas if the laser beam is monochromatic, then it means that the photons are of single wavelength or same wavelength and have only single color or one color. And the laser beam is parallel because all the photons move in only one direction and there is very little dispersion in the lasers. Next question, what are the laser knives? As we know that laser is intense light, so highly intense light. So the energy produced by these lasers can be used for cutting different materials. So it has the applications in industry and medical field. In case of surgery, lasers are used to cut the blood vessels and make it easier to control the bleeding. Also, it is used in removing the tumors. Thus, the laser light behave as a knives in different surgical procedures. Also, the laser knives are also being used in industry to cut the different materials such as glasses, paper, and plastic. The next question, why we cannot see? As we know that we can see an object whose size is greater than the wavelength of light. So an atom is much smaller than the wavelength of visible light, so we cannot see them by using the optical microscope. Only those objects become visible whose size is greater than the size of wavelength of light being used. As the size of atom is of order of 10 is per minus 10 meter, whereas the wavelength of visible light is of order of 10 is per minus 7 meter. So the wavelength of visible light is greater as compared to the size of an atom, so it is not visible with the help of visible light. Next question, what is meant by breaking radiation? Breaking radiation or the Bremsstrahlung phenomena. What is the Bremsstrahlung phenomena? Whenever the electron is strongly deaccelerated, then according to classical theory, whenever a body is deaccelerated, it emits radiation. This can be understood by a simple example. When a car is moving, it has the kinetic energy, and when we apply the brake and car stops, so it means that its kinetic energy becomes equal to zero. So where this kinetic energy goes, so this kinetic energy is being radiated in the form of heat radiations. So similarly, when a particle or an electron is strongly deaccelerated, then its energy is being released in the form of radiations or X-ray radiation. So we can write its answer as when a high energy electron strikes and enter the target material, it undergoes the deflection on passing close to the positively charged nuclei. So during the deflection, the path of electron becomes curved, which gives rise to the deceleration in the electron. So according to classical electromagnetic theory, an accelerated electron emits the radiation. So these radiation appear in the form of photon in the X-ray region called breaking radiation, or this phenomena is known as Bremsstrahlung. Last question of this exercise is, what is optical pumping? Optical pumping is the process in which the photons are used to excite the electrons from lower energy state to higher energy state. So the process in which high intensity light is being used to raise the electron of atom from the lower energy state to higher energy state is called optical pumping. And in case of laser, to achieve the population inversion, the optical pumping is commonly used in laser construction so as to achieve the population inversion. Then according to the smart syllabus, only two last questions or numerical problems are included. So question number 11, in an X-ray tube, the electrons are accelerated through a potential difference of 3000 volts. So electric potential is 3000 volt. Planck's constant value is 6.63, and charge on an electron is 1.6 into 10 is per minus 19 coulomb, and speed of light is 3 into 10 is per 8 meters per second. So if these electrons are slowed down in target, what will be the minimum wavelength of X-rays produced? As we know that whenever the electron is accelerated through some potential V, so according to the definition of electric potential, as you have studied in the first chapter, that is equal to W over Q. Work done on unit positive charge is called electric potential. So work done will be equal to Q multiplied by V. In this case, the work done will be stored at its kinetic energy, or this is equal to kinetic energy is equal to Q V. So when an electron is moving with the kinetic energy is equal to QV and it strikes with the target material and it gets slowed down, so its kinetic energy is converted into X-rays of energy HF equal to Q into V. As frequency is equal to F is equal to V over lambda or C over lambda. So by putting this value, we get the relation HC over lambda minimum equals to VE. Or we have to find the value of lambda minimum. So lambda minimum is equal to HC over VE. So by putting the above values, we get the answer 4.14 angstrom or 10 raised to power minus 10 meter. And the last numerical which is included, that is again the same problem. Compute the potential difference. In this case, we have to find out the potential difference V, through which an electron must be accelerated in order to get the shortest wavelength of limit of continuous X-ray spectrum, that is 0.1. So wavelength is equal to 0.1 nanometer or zero point 0.1 into 10 raised to power minus 9 meter. And again, the constant H and E and C. These are the constant having the values 3 into 10 raised to power 8 meter per second, E 1.6 into 10 raised to power minus 19 coulomb, and H is equal to 6.63 into 10 raised to power minus 34 joule second. So again, the relation is same. HF is equal to VE, that the kinetic energy of the electron is converted into photon energy, HF equal to VE. Again, putting the value of frequency, F is equal to C over lambda. We get the relation HC over lambda minimum equal to VE. So from this, we can find out the electric potential V is equal to HC over E into lambda minimum. So by placing the values, we get the answer 12400 approximately. So this was the today's lesson. Thank you.